do this two steps today, and one thing I want you guys to remember is that when you do a problem like number 1, you should know how to check it. But checking is time consuming too, so I don't know if anybody remembers what I said yesterday. Try to check maybe 4 or 5 a night. So if you have 20 problems, check maybe 4 of them. And the rest of them you can check in your head, but practice checking. When you take a test, we'll actually have you show how you do your check. So keep that in mind. So the check would be like making sure the answer actually works. Okay? The second thing I want you to think about is, what are we really doing here? Like, what's the point of these problems? So last night's problems were pretty straightforward. So you can kind of visualize the answer, but let's say you can't and you just had like a little box here. You're trying to figure out, if your x value was covered up, what missing number would work here. You're trying to figure that out, okay? So what x value would make that work? And they get harder and harder to do in your head. But since we're solving for x, we're going to undo the problem with basically reversing order of operations, because we're undoing. So normally in order of operations, you always do the adds and subtracts first, and the multiplies and divides after. So if we're solving for x, and we want to isolate x, I think it can be really helpful for some people to just sort of put a little box around x and try to get everything moved away from it. But you have to go in reverse order of operations. So instead of doing the adds and subtracts for last, we're going to do them first. So we're going to do the opposite. So we're going to treat this as a 2-step problem, but we would do the undoing of the addition first by doing the opposite. So instead of adding 5, we want to get rid of that, so we would do what to both sides? Yeah, so you would just put a -5 here and a -5 here, and that's your step 1. Okay, so put a first over here. Then you can draw a line. These cancel. So you bring down what's left on the left-hand side.
Can you make each step a different color?
I can. And then this is 10. So far, I've done 1 step. But I still have my x in the problem. I still want to get that all by itself. Does that make sense? So now, the operation that's happening between the 2 and the x is multiply. So I'm going to undo the multiplication with the opposite operation. And fraction bars mean divide. So I'm going to divide both sides by 2. And 2 divided by 2 cancels out to be a 1. So now we have just an x, and x is 5. And that should be correct, but it's really easy to make a careless mistake. So you want to make sure you understand how to check your work. Okay, Natalie. We'll do more than 1.
How do you get the 5? How do you get the 2?
That's the 2 times 2, so you divide it by 2.
15 minus 5.
Because the operation that I'm trying to undo is multiply right here. And since I'm taking the x value times 2, I want to get x alone, so I have to get rid of the 2 by using the opposite operation. So I use the fraction bar. And I divide by what I'm trying to eliminate. And we'll do another example. I've got a few here. Okay? Cameron.
Or can you do it a different way?
That's the only way that would work. Let me hear what you're saying. Maybe you're thinking of something.
I just put that problem, and then beneath it, I wrote 2 times blank equals 50 plus 5 equals 15. And then I try to figure out what 2 times something equals 10.
So you're doing it in your head with mental math.
Yeah.
That's good intuition, but as these problems get bigger, it's virtually almost impossible to do the harder problems. So I'm not saying that you can't get a correct answer using mental math, but we're practicing basically the two-step method today. So you do need to do the steps. But having the skill to do that in your head is really good because, like I said, you're not going to check every single problem tonight, but a mental check is great. So to check the problem, I'm going to do 2, and I'm going to take my x value of 5, and I'm going to stick it in for x. So instead of 2x, I'm going to say 2 times my answer of 5. And add it to 5, and I'm going to see, does this equal the right-hand side? It should equal 15 if it works. So 2 times 5 is 10. 10 plus 5 is 15. These are the same, so it works. So we say it checks. Natalie.
So, I'm just confused why you got the -5.
Because we're doing the opposite operation. So do you remember last night, like with the problems you did? You undid one step. So let's say I bring an example in, okay? Let's go to something similar to last night. If you had like z plus 5 equals 20, okay? To undo that, you would have to, in your head, you would be thinking, I need to find a number to add to 5 to get 20. What's that number just in your head? 15, right? And that's the same as 20 take away 5, isn't it? So the one step that you show is subtract 5 from both sides.
Oh, so it's not -5.
No, it's just to subtract. And so this cancels and you get z equals 15. Okay, so when we go back to this page here, that's basically what I'm doing. I'm just waiting on that piece and getting rid of things that are getting rid of all the adds and subtracts. Okay? It's almost like you look at the variable, the x, and you move away the things that are farthest first. Okay, I mean, you can think of it that way too. So let's practice with another one. Okay, so on this problem here, I'm going to do the same thing. I want you guys to think about isolating the x. So Natalie, you have to undo this problem in reverse order operations. So what's the first thing you're going to move or get rid of? So look at the last one. What did we use up here? What did we do first in green? So you undid the add, right? So here, what do you think you're going to undo? Right. So the opposite of subtract is add. So you're going to add 7 to both sides for your first step. That's your first step. Okay, so when I do that, what do I get on the right side? 30, right. Okay, and then what happens with so the subtract 7, you could think of it as a -7 plus a +7. You could think of this right here as a -7 plus a +7. So what does a -7 and a +7 make? 0. So they cancel out, so we just draw a line through them. Okay? Does that make sense? And then you bring down the leftover part of the problem, which is 3x. Okay, and then remember, you're trying to get x all by itself, so what would I have to do next? What operations here? Yeah, you would divide by 3, because the 3 is being multiplied by the x. So the opposite of multiply is divide. So we use a fraction bar to show division. And so on the left-hand side, 3 divided by 3 is what, Will?
10.
Oh, that's the right-hand side. And over here, these cancel to just be x. And that's your final answer. And if you want to check to see if it works, which is a really good idea, you would plug it in for x. So you would copy the problem and do 3 times your x value of 10, which is 30, take away 7, and you get 23. And if you look over here, that's what we were trying to get, so we say it checks. I don't know if that makes sense. You want to try one? I think you should try one. Let's see. What do I have on the next page? Get rid of that. Let's try. Make one up for you. Okay, so let's have you try. 6x take away 3 is equal to 51. Work it out with the steps. Yeah, Noah. Right. Right. Try it yourself though, so you're on the right track, so everybody can see if they can do it themselves. Let's try that. Okay, Zig, what'd you get? I mean, Xander, what'd you get? Haley, you got the same thing? Okay, so let's do Noah's first step. Add 3 to both sides. And then on the right-hand side, you have 54. On the left-hand side, you just have 6x because these cancel. Does that make sense? And we're trying to get everything away from the x. So what'd you do next, Xander? Right. Yeah, because 6 goes into 54 9 times. All right, raise your hand if that makes sense. Better now? Was it? Okay. Let's go to this type of problem. So this is a little different, but it's just your last example for today. It looks a little different, but when you compare them side by side, really the difference is that in problem 1 up here, you had 2 times x, right? And over here, whoa, that's not it. So over here, basically what we have is x divided by 5. So we have a different operation, but the idea is the same. So we still have to go through the rules of undoing in reverse order of operations. So let's see. Skylar, what do you think you would do first?
I think you do the division first.
No, because
Oh, you took plus 3.
yeah, you have. What do you have to get rid of first?
The 3. So
Yeah, you have to undo the adds and subtract. So you would subtract 3 from both sides. Okay, now this is a little trickier. These cancel. So on the left-hand side, you have x over 5.
And then that's negative 20.
Yes, good job. So this is negative 20.
And then you have to do
So now we're still trying to get rid of the x, right? So we have to eliminate opposite of division is, so we're going to just show that with a 5 times here and a 5 times here. What happens with the 2 5s?
they cancel each other out.
They make a 1, right? They cancel each other out, so you have 1x,
And then equals
negative 100. And if you did a quick check, you would say negative 100 over 5 plus 3, and hopefully that's going to equal negative 17. So what's negative 100 divided by 5? Negative 20, right? Negative 20 plus 3? Negative 17. So it checks. Okay? That's what your homework's like. Yeah.
So is that like 3 problems, or is it like 3 steps? Because
That's 2 steps.
well, because you did minus the instead of the opposite of adding and subtracting, and the opposite of dividing is multiplying.
Right? So first I undid the subtraction with, I undid the addition with subtraction. That was step 1. Okay? That was our first step right there. And then the second step was that I undid the division by doing the multiplication. That's it. 2 steps. Okay? All right. So I'll put